So good morning. Very good morning. Right. Let us conclude the electrical measurements now. Only small topic is left over. After that, few questions will be done and we'll close the session. Here. This is the homework question I gave you in the last class. Right. Okay. Now, here, for the bridge circuit in the figure, the voltages are V1 is given, V2 is given, and VD is 0 means what is that? The bridge is balanced. The bridge is balanced. But in this circuit, supply is not given from outside. Supply is given in the corresponding bridge branches only. That's why concentrate. Here I'm modifying the bridge. I'm modifying the bridge like this. This is one branch. This is one branch. Okay. Just I'm rotating the diagram to have the clear picture like this. Between these two, it is anyway drop or nothing but simply VD equal to 0 means this potential and this potential both are equal means it is balanced circuit only, right? So what is this value? R is equal to 100 ohm, Zx is dash, this is V1. Sir, what is V1? Root 2 cos 1000 t. Concentrate. Root 2 cos 1000 t. Okay. And V2 is 2 cos 1000 t plus 45. 1000 t plus 45. This is a given data. Sir, the value is given in which form? Instantaneous form. The value is given in instantaneous form. So let us convert this into polar form. What is that? Root 2. What is angle here? Nothing is there. Root at an angle 0. Right? And here 2 at an angle which value? Plus 45. Right? Those who are done with the network theory, they know that. Otherwise, take it for granted. Instantaneous form. Root 2 cos 1000 t. Angle is not there. Simply root 2 at an angle 0. 2 cos 1000 t plus 45. 2 at an angle plus 45. Okay. Now, sir, this potential is equal to this potential means voltage across this and voltage across this. These two will be same only. Clear? Right? So therefore, this V2 appeared across this. The V2 will be appeared across this because these two voltages will be equal. Why? This potential means with respect to this node, with respect to this node will be equal. I told you in the same way. So this side potentials are also equal under which condition? Balanced condition. So therefore, across this V1 is applied. This was the first observation in this question. Clear? Right now, sir, as these two are coming in series because it is balanced circuit means these two are coming in series. So therefore, what we can write now? Current I, same current I will be flowing here. Same current I will be flowing here. Right, sir? What is V1? What is R? We need to concentrate here. Sir, what is I? I is equal to V1 by R. Here also I is equal to V2 by Zx. That only we have to write first. Sir, I1 is equal to V1 by R. Otherwise, simply I is equal to V1 by R. Sir, what is V1? Root 2 at an angle 0 by R is 100. Root 2 at an angle 0 by 100. Okay. In the same way, I is equal to other side. Sir, voltage V2 is appeared across this branch means V2 by Zx. I is equal to V2 by Zx. Right? Okay. Sir, what is V2? 2 at an angle 45. 2 at an angle plus 45 by Zx. Right? This is equation 1. This is equation 2. Sir, I and I both are same. Why? These two will be in series. Why? The bridge is balanced. If these two are in series, automatically we can write from equations 1 and 2. From equations 1 and 2. What is that? Root 2 at an angle 0 by 100 is equal to 2 at an angle plus 45 by Zx. So from this, what we can write? Zx is equal to 100, 200 at an angle plus 45 by root 2 at an angle 0. So what we can write now? 200 by root 2 means 100 root 2 at an angle plus 45. At an angle plus 45. Right? After that, this is a polar function, polar form. But what he is asking, resistor, inductance, like that, series or parallel, like that he has given. So that we need to convert this polar form into rectangular form compulsory. So therefore, we need to convert this. How? Zx is equal to 100 root 2 at an angle plus 45. Sir, if you convert this into rectangular form, you will be getting 100 plus j 100. If in doubt is going the reverse way. Root of 100 square plus 100 square, 100 root 2. Tan inverse 100 by 100, 145. Sir, what does it mean here? This is the Zx value. So this is in the form of R plus J, which value? XL. So R plus XL means, what is it? R and XL, R and L both are in series. Okay, therefore, what we can write? R is equal to 100 ohm. Sir, R equal to 100, 100, 100, 100. All options are equal to 100 only. So therefore, you have to take XL is equal to 100 ohm. So what is XL? Omega L. So in the omega, in the question, what is omega? 1000 T, because omega T we can say. So simply, omega is 1000. Substitute here. Therefore, L is equal to 100 by omega. 100 by 1000. So what will be there? 100 milli. This is 100 ohm. This is 100 millihenry. Clear? So therefore, what we can say? These two are in series anyway. Why? R plus JXL form is series. So therefore, answer is 100 ohm, 100 millihenry. 100 ohm, 100 millihenry series. What is the answer here? Option A. Right? Suppose if you are getting here minus symbol, for example, then that will be capacitance function. Then the option B will be capacitance value, may be anything, but idea purpose. So this is the total discussion regarding which one here? Bridges chapter, and one homework question I gave you, I solved it. Clear? Right. Let us solve few more questions in the bridges chapter. Try this. Those who are on the line, kindly try this. Come on. Yeah, almost all people are giving answer as option B. This is what the confusing point. Almost all are giving as option B only. Try this. Try. Option A. Yeah, few people give that option A, and a few people are giving that option D. Okay, all options are covered. Is there anyone giving C option so that all options will be covered? Right. Concentrate here. What small change here is here. This is the resistance R, capacitance XC, resistance R, here, 10 volt, right? The bridge here, this voltmeter reads, so this value we require. Okay, so what is this value? V not I'm writing. This is C and this is D I'm taking. So that's why be clear, guys. Here, don't be in hurry. Don't be in hurry, right? People are thinking that, sir, XC by R equal to 1. Sir, 1, 1, 1, 1. So all are equal to 1 into 1, but you're missing something. Here, angle is also playing the major role. Magnitude is given 1, 1, 1, 1. Magnitude is given 1. But here, XC means capacitance means it is having real part and imaginary part. Capacity means only imaginary part. So that's why be clear with the terminology. Right? Now I'm doing now concentrate here. Small logic, small thing. So what is VC and what is VD? Let us find out. Sir, let me find out VD first. What is VD? These two are in series I'm taking. I told you, in order to find out these two, in order to find out this value, you need to take this as a series. So what is value? Simply 10 into R by R plus R, that is 5 volt. That is 5 volt. Clear? After that, sir, what is VC? What is VC? Concentrate here. VC is the voltage across this. Yes or no? What is that? XC. So therefore, 10 into minus JXC by R minus JXC. 10 into minus JXC by R minus JXC. That's what the actual point here. Clear? But what people are taking 1 by 1 plus, no, yeah, this is real and imaginary. That's why I gave you, before starting the AC bridges, I gave you clearly, we need to concentrate on both. We need to concentrate on both magnitude as well as angle, right? So therefore, here what we can write, 10, right? This is taken as which value? Minus jxc, xc equal to 1. So simply you keep it as it is. What is its magnitude? Here I'm writing like this: vc magnitude. Why? All I told you, you can take vc minus vd or vd minus vc, anything you can take. So that's why you can write like magnitude like this directly, right? Otherwise, so v naught equal to vc minus vd, vc minus vd. Generally we are talking about only magnitude, because even though you're getting minus symbol, what I told you, yes, you need to take plus symbol notation only. So therefore, what is vc? 5 minus this value, minus 10 minus j10 xc by r minus jxc, r minus jxc. Clear? Now simply 5r minus j5xc plus j10xc by r minus jxc. So 5r, here it is, plus. So therefore 5r, what is the value? J5 plus j5xc by r minus jxc. So I'm taking 5 outside. What we can write now? 5 into r plus jxc by r minus jxc. This is equal to v naught, right? So 5. Now I'm writing v naught magnitude. What is the magnitude of this one? Root of r square plus xc square. Here also magnitude r square plus xc square root. So automatically, so therefore, what is it? V naught is equal to how much value? 5 volt. This is what the confusing part. So that's why be clear with the corresponding terminology. Many people gave that answer as 0 volt. Many people give that answer as 0 volt. But answer is how much here? 5 volt, not 0 volt. Because it is given as Rx is simply 1, 1, 1, 1. But here angle is there. So angle is playing the major role. So that's why I've taken minus, plus, jx, etc. Otherwise, you will get the 0. But that is wrong answer. Any more confusion? Kindly let me know. Generally, many people give the generally 0 volt only will be given by you people generally. Got it? So that's why in the AC bridges, you need to concentrate on magnitude and angle in the corresponding voltage drop or corresponding impedances. Finally, you can take the corresponding value. Right. Sir, how will be the V drop in diagram? What do you mean by money one in this? Here only V drop. Here only V drop will be there. Because all these magnitudes are equal, but angle is there, no. So therefore difference will be there, because 5 is different from 5 at an angle 90. 5 is different from 5 at an angle 90. That you have to concentrate. Therefore, yes, voltage drops will be correspondingly taken. But across resistor and XC. So concentrate here. This voltage drop VC equal to, again you forgot, kindly go to the complete notes. VC is the voltage drop XC, VD is the voltage drop across R. I have taken like this. Otherwise, VC is the voltage drop across this, VD is the voltage drop across. You can take any notation, you will get the answer. But all I told you, with respect to negative polarity, means this is positive, this is negative notation. So this one only we have to take. I told you in both the ways, you can go for it, no problem. Right? Let me take one more question. A simple conceptual question I'm giving. Like this is also possible, because in the 2020 paper, this type of question is given for electrical people. Right. Very simple. Conceptual question. Chance is there. Here, low value of R. Low value of R. Kelvin double bridge method. Right. High value of Q. Hayes bridge. Right. After that, capacitance sharing bridge. And inductance is Maxwell's Wains bridge. Nothing but Maxwell's inductance capacitance bridge, like that we can see, no problem. Yes. In that way also questions are possible, because in the 2020 paper, which of the following is used to measure the inductance? Direct question he has given. Frequency, Wien Robinson, simply Wien's bridge, right? And self-inductance, Anderson's. Capacitance, sharing bridge. Mutual inductance, I gave one note, right? Even if it is not there, but match the following, they may be asking. If all options are matched, automatically mutual inductance will be matched. In that way also questions may be possible. Gate 18 question, numerical model. Try this, complete numerical model. You need to understand it is which bridge. Based on that, you can use the formula, and I told you to practice all the bridges also. With the simple shortcut note, I told to practice. So kindly give me the answer. Right? Is asking only LX. Yes, this bridge is MICB. This bridge is, see, RL series and RC parallel. So which bridge? MICB only. Automatically MICB. Yes, Maxwell's inductance capacitance bridge. Now, what is the answer for this? What is it? LX is equal to R2, R3, C4, direct formula. What is R2, R4? Okay, he has changed the numbers, so kindly follow these numbers only. And generally, what we take now, see, this is one number here changed, numbers here changed. So according to that only, you need to take it. What is that? LX is equal to, what is it? R2, R4, C1 in this, because numbers only changed. Everything is same, but only numbering is changed. All values. What is that? R2. 22.2 into 10 power 3 into R4 10 into 10 power 3 C1 1 into 10 power minus 9. Here 22.2 into 10, 222. Here also people are getting confused. 10 power 6 and here 10 power minus 9 means minus 3. So therefore 222 millihenry. 222 millihenry. People are giving 0.0000. Come on here. It is 0.222 or 0.0002. 0.222. Nothing but 222 millihenry. This is very simple when you are able to recollect the formula. Otherwise, it's very, very difficult. So be clear. One more conceptual question. Direct question. See, sharing bridge capacitance, Desaut is capacitance, Wien's bridge frequency. So Heaviside Campbell's bridges means modified bridge mutual inductance. So automatically, what's the answer? Option A. Like this also chance is there. Right. So this is the total discussion regarding bridges. Almost all questions we have done already, but just only one homework question, etc. Clear? Right. So this is the total discussion regarding entire electrical measurements, but few miscellaneous topics are there. Just I'm giving all those. In the gate, those are not mentioned clearly, but you need to know those. And in the ESC objective, so and so direct questions will be there. That is power factor meter. Power factor meter. Concentrate here. So what do you mean by power factor meter? Simple idea I'm giving. Sir, first of all, how the power factor meter scale will be, concentrate here. This will be the power factor meter scale. Generally, power factor will be varied from 0 power factor lagging to 0 power factor leading. So therefore, here I'm taking ZPF leading. Here I'm taking ZPF lagging. And here, center UPF. Right? This entire thing is just lagging. This entire thing is just lagging. Here, this entire thing is just leading. Right? Here, lagging, and this is leading. So my question is, sir, each and every scale value is representing one of the load power factors or not? Definitely. If the pointer is showing like this, what does it mean? 0 power factor lagging means pure inductive load. Suppose it is showing like this, means RL load, resistive load, RC load. Here it is pure capacitor load. So my question is, in the entire instrument scale value, which should be taken as the no supply connection, no supply condition, or no supply given connection, or we can say no load is not connected, supply is not given, etc. Tell me. People are saying that UPF is taken. Come on here. In the answer, in the statement itself, this question is there. UPF means what is it? Unity power factor load means resistive load is being connected. Can you take this as the supply is not given, the no load is not given connection? No way. That's why one thing. People are saying that, sir, ZPF lagging. How can you take ZPF lagging? You need to understand one point. One second. You need to understand each and every scale value is indicating one of the loading conditions. Are you clear? If each and every scale value is showing or representing one of the loading conditions, how can you take one load as, how can you take one scale value as initial value? No way. Be clear, guys. People are thinking like, sir, 0 is there. It is 0, but 0 power factor leading means pure capacity load. 0 power factor lagging means pure inductive load. UPF loading means pure resistive load. Like with this one is RL load. This one is RC load. Means each and everything is with respect to one of the loading conditions. Each and everything is with respect to one of the loading conditions. That is the reason why, consider guys, that is the reason why nothing will be taken as the initial value. Suppose if I take one ammeter, this is 0 to full scale value, some ammeter, voltmeter, wattmeter, etc. Sir, in this case 0 and full scale value is there? No. Yes, sir. In this case, which is to be taken as the initial value? Obviously, 0 is to be taken as the initial value compulsory. Why? 0, if the pointer is showing 0 means that instrument is in our hand, that instrument is in the almirah, supply is not given, load is not connected, not excitation. That's what the point. So therefore, yes, 0 is taken as the initial value. So therefore, the point is, so in this instrument, what did we do? Did you remember? Here, the pointer is showing like this, for example, some 4. Okay, my experiment is done. After my experiment, after completion of my experiment, if I switch off the supply, the pointer has to go back to its initial value. The pointer has to go back to its initial value. That's why what did we use? We have used the spring type of arrangement. During the operation, the springs will be getting disturbed, means the force will be developed. What I told you, if the supply is switched off, the springs will be trying to go back to their original position. The springs will be trying to go back to their original position. So automatically the pointer has to move back to 0, because in this type of instruments, 0 is called as initial value. That's why the pointer has to go back to its own initial value. That's why springs we used. But in this, concentrate here, sir. In this entire power factor meter, right? Suppose I have connected some load, some supply is given. Assume that it is showing some 0.6 lagging, for example, or 0.4 something lagging. It is showing. Okay, well and good, sir. After switching off the supply, this pointer has to go back to which value? The pointer has to go back to which value? That is what my question. The pointer has to go back to initial value. People are saying like this. Come on, guys. In this, nothing is the initial value. That's why I already told you, nothing is the initial value. That is the reason why in this spring controlling method is not used. Spring controlling mechanism is not present. Which is not present? Spring control mechanism is not present. Sir, why? Means here, if it is showing like this, after removing the supply, the pointer has to go back to initial, means nothing is initial value. That is the reason why we should not use the spring control. If you use a spring control, what happens, sir? The moment supply is switched off, the pointer has to go back to its initial value. The pointer has to go back to its initial value, but nothing is initial value here. That is the reason why. In this spring control mechanism, in this meter, no controlling mechanism is provided. No controlling mechanism is provided. Very, very, very important objective question, right? In which of the following instruments controlling mechanism is not provided? Ammeter, voltmeter, wattmeter, power factor meter. Automatically power factor meter. But immediately one more question comes into picture. Sir, if controlling mechanism is not provided, how the point, suppose pointer is moving like this, it has to stop, means in this direction TD is there, from this direction TC should be there definitely, otherwise it will not stop at this point. So therefore, sir, if the controlling mechanism is not provided, how the pointer gets stopped? How the pointer gets stopped means, be clear, try to understand the terminology here. No controlling mechanism is provided means the meaning of the statement is, the, what is it here? Restoring the pointer moving back to 0. That mechanism is not available in this and should not be available, because there is no corresponding initial value at all. So that is the reason why the restoring force, nothing but moving back to 0 related force, is absent. But opposing force is produced. That is what? That is construction based. The opposing forces the opposing forces are produced. The opposing forces are produced by the coils itself. By the coils itself. This is what the actual thing. Right. Harshvardhan, correct. Right. But generally, option given like power factor meter only. In this meter, no controlling. Everyone I'm repeating, no controlling means what do you mean by that here? Restoring means the pointer moves back to zero. Position is not to be there. That's why spring mechanism is not used. Controlling mechanism is not used means spring is not placed. Okay, but opposing force is required definitely. The pointer has to move like this means TD will be there. Opposing force is to be produced. How the opposing force will be produced in this meter means by the coils itself, means the coils are designed such that the opposing forces will be produced automatically. That is depending on its own construction. But you require up to this only in the gate point of view and ESC objective point of view. But ESC people, when I take the conventional one, power factor meter complete figure and a complete derivation, everything I'll be taking. That's what the point. So this is very important point in the what is it? Competitive examination. What is it? Which of the following meter is not provided with controlling? I'm repeating, controlling is not there means which one here? Spring type controlling is not there. Means the moving back to zero position is not there. But which one here? Opposing force will be produced that to by the coils itself. By the coils only the opposing force is produced. This is very important point. But construction, diagram, etc. not required. No need to worry. In the ESC conventional, I'll be taking that. No need to worry. Today, I'll tell you know all miscellaneous topics only. Safe side, I'm giving all these points. Right. It will be there at reading point only after measurement. Yes, definitely. I'm coming to that only. And one more student is asking that not only this, I'm giving here, I'll be giving, right? No need to worry. All the points will be given. Today class is being taken to give all varieties of questions. Nagasai Manikanta Kumar, let me explain. The point here is, as a topic is there power factor meter. But here in Megger and in power factor meter, right? No controlling mechanism. No controlling mechanism. I told you at the time of Megger, in the simple objective way of explanation I'm giving, but in that entire Megger, construction will be there, some machine type construction will be there. That is generally taken the conventional paper only. I told you. Yes, in Megger, in power factor meter, some other meters also there, flux meter, etc. But those meters are not there nowadays. No need to worry. One more thing. People are saying that, sir, while we are solving, yes, very good, but be clear. Here, you people are solving the questions from entire measurement subject from 1990s to approximately 2021. I told many of the times syllabus has been changed many number of times. Those questions are the fluximeter questions, or some other questions were there in the vibration galvanometer, ballistic galvanometer, DRSM galvanometer. Those type of questions were present long back. So nowadays not there. That's why latest syllabus based only prepare. But in the previous questions booklet, we cannot remove all those questions. So that's why we are giving all those. All I told you this, follow this booklet, but according to the present syllabus. According to the present syllabus, you need to follow. Same problem in all the subjects. People are saying that, sir, the topic is not done. The topic was there. The topic is not now. That's not the point. The topic was there, but the topic is not there now. That is the main point here. Clear? Right? So that's why kindly, this is the miscellaneous topic. Okay. Sir, I am the operator. I operated according to my supply and load. Okay. My load related value is shown here. Okay, my experiment is done. I switched off the supply. If I switch off the supply, where will be the pointer? Where the pointer means, does it move back to any initial value? Nothing is initial value. That's why it will be there. It will be there itself. That's why the pointer will be stayed. The pointer will be staying at the previous value measurement only. Suppose this 0.6 for example. Yes, it will be staying there only. Okay, my experiment is done. I switch off the supply, it will be staying. Suppose you are connecting some other load. Yes, according to that load, the pointer will be moving either this side or this side. That type of arrangement will be there in the construction. No need to worry. Therefore, it may be coming here, some 0.5 or zero point 0.6 leading, etc. And if you are switching on the supply, it will stay there only. That is the reason why it is called as no controlling mechanism, but opposing forces are produced by the coils itself. This is what the complete discussion regarding power factor meter. Right. Concentrate here. People having this is $1,000,000 question. All I told you, I'm repeating. Notes is more than enough. If you cover notes, right? Concept, complete concept. No single topic is skipped, and the two, some topic to topic, chapter chapter, miscellaneous topics also I have taken every time. Finally also I'm taking all the miscellaneous. No need to worry. Concept will be there, questions will be covered. In this, practice questions will be there, previous gate covered, previous ESC also covered. After that, some extra questions, whatever the material you are having, practice that. That's it. Extra questions, previous and etc. You follow. More than enough, right? The complete note, concept wise, you can write any examinations with this concept. No need to worry. No need to worry at all. Right. So in 2020, cycloconverter comes from out of syllabus. Cycloconverter is not measurement. Ankur, my subject is measurement. Kindly concentrate. My subject is measurement. Right. And one more thing, sir, damping torque will be generally common here. Damping torque, why? Here, from one side, TD, from other side, which one here? TC. So definitely damping torque will be commonly present. Which type of damping torque we use? It is, what is it here? Electromagnetic type of meter automatically means power factor meter means EMMC notation only, air friction damping notation we can say. But damping torque, no need to concentrate that much. Right? And scale is linear or non-linear. Scale is generally uniformly distributed generally. But strictly speaking, power factor meter, no, yeah, power factor cosine based itself is, what is it here? Non-linear scale only we can say. But in the designing point of view, they may be giving equal division notation, no problem. But generally we say power factor itself is cos phi non-linearly changing, so automatically non-linear scale. No need to worry. Clear? Any more confusions? Right. Now, one more point is there, that is frequency meter. Frequency meter. So what is frequency meter? Here, in this generally, one type is there, electrical resonance type frequency meter. Electrical resonance type frequency meter. This is generally a common type of frequency meter. Other devices are there, but this is generally there in the topic wise. That is miscellaneous topic only I'm taking. Electrical resonance type frequency meter means simply you are getting like electrical resonance type frequency meter works on the principle of dash, which is electrical resonance only. That too, series resonance concept, XL equal to XC concept, it will be working. That's why concentrate here. Sir, here, what is the resonance topic here? XL is equal to XC. This is the main concept. So this is called as resonance condition. Based on this only, the entire device is operated. XL equal to XC, resonance condition based, it will be operating. How means, suppose, so for example, if XL greater than XC, for example, by giving something, if XL is greater than XC, for example, what happened, this XL will be reduced, and equal to XC. I'll get my point or not? If XL is greater than XC, for example, slowly XL will be reduced, and become equal to XC. Sir, XL equal to XC is resonance condition. The pointer will be stopped. Simple idea I'm giving. Suppose if XL is less than XC, for example, then XL will be increased. XL will be increased, and becomes equal to XC. Then the instrument shows the pointer. That is what the overall concept. But how everything I'll be showing, concentrate here. Right. I'll be taking the figure, then you'll get more clarity. In this, because it is electrical based concept, so that I'm showing the figure, kindly wait for 1 minute. This is the electrical resonance type frequency meter. Concentrate here. This entire instrument is designed such that here the instrument is under normal operating condition with XL equal to XC. If XL equal to XC happened, the pointer will show corresponding frequency according to the given supply. Simple idea. After that, so normal frequency in our India, which is the normal frequency? 50. Yes, 50. More than 50. I am designing for 52. I am designing for 48 to 52. Equally, I am designing. Right? Generally, frequency will not be varied more than this range. Yes or no? Our India frequency is 50. But do you see like 40 hertz, 20 hertz, that much variation? No. 50 means plus or minus 0.5, plus or minus 1 maximum. So therefore, 50 to 52, 50 to 48 I'm taking. This is simple. Now, in this entire thing, how the construction, concentrate here. This entire vertical rod is in a vertical bar. That is, what is that? Moving coil. That is moving coil. Whatever this curved portion is there, that curved portion is laminated iron core. This entire curved portion is laminated iron core. And this entire thing is magnetizing coil. Means on this iron piece, some magnetizing coil is placed. Okay, I'm coming again. Supply given to the magnetizing coil, which is placed on the iron core, laminated iron, and this will be the fixed one. This will be the fixed one. This is fixed, but this is moving. Okay, and that will be, kindly look at my hand. This is there like this. No, don't think like it will be moving like this. No, it will be moving like this, because our pointer is angular movement. No, yes, the pointer will be moving like this. So therefore, here this entire portion will be attracted by the coil or repelled by the coil. So thereby the pointer will be showing this side or showing this side. That's what the simple arrangement. Okay, this entire box is moving coil, but it is placed with capacitance. So therefore, this moving coil is equal to RLC circuit. Moving coil is equal to RLC circuit. This is the general construction. Construction part is clear? Is construction part clear? Not required, but just idea purpose I'm showing, because resonance topic, no. So automatically in other subjects also resonance part will be there. That's why I'm giving. Right. Now be clear. Sir, this is designed for 50, 52, 48. No, if I give, actually we don't know. Suppose if unknown frequency is 50, for example, if unknown frequency is 50, for example, if the unknown frequency is 50, right, based on this entire supply, it will be getting magnetized. Based on this magnetization, flux will be there. That flux will be linking with the coil. Concentrate, guys. The flux will be linking the coil. In this coil, EMF will be induced. This EMF produces the current. This EMF produces this current called as IM, moving coil current. So no, then this current will be concentrated here. This current will be in phase with E, in phase with E, such that only the entire coil, magnitude, coil structure, number of turns, everything will be designed. What is it? Concentrate, guys. I'm coming again. Small complexity, but simple concept only here. 50 hertz supply is given. For example, this is given for 50 means normal means I am the manufacturer. I am designing the instrument such that 50 hertz frequency is my normal frequency. 50 hertz frequency is my normal frequency. That's what my point. So therefore, how I have to design the circuit means if I give the 50 hertz, based on this 50 hertz supply, magnetization will be there. This magnetization gives flux, flux linking with the coil. That coil, what is that here? In the coil, EMF will be induced, current will be produced. Then in the circuit, as the current is flowing, means the flux magnetization will be there. No, then the inductive reactance of this moving coil XL should be equal to capacitive reactance of this element XL equal to XC. If XL equal to XC, then the correspondingly pointer will show the 50. In that way, the corresponding circuit, coil, number of turns and all, capacitance value will be, should be chosen by the manufacturer. Are you clear? If you understand this statement, the thing will be very, very clear. Now let me know, is this statement clear? How the structure is designed, how the capacitance value and the coil value is taken, how the capacitance and how the in the coil value is being taken. Right, I'll explain again. Concentrate, Sirisha, concentrate, no problem. Here, simply, sir, how much is the capacitance value? How do we know? How much is the number of tons? How do we know? That's what I'm saying. I'm designing for, means we are the manufacturers designing for 50 hertz frequency as the normal. Higher will be anything, lower will be anything. That depends on our requirement. Sir, if I give the 50, this coil should act as XL is equal to XC. XL equal to XC, then the coil will be acting as resistive. If the coil is acting as resistive, then the pointer should show which value? 50 exactly. In that way, the coil number of turns and the capacitance value will be, should be chosen by the manufacturer. This is what the point. Okay. Now, under that condition, initial condition, the pointer is at which value? Yes, under initial condition, the pointer will be at which value? 0. Nothing but, sorry, 50 hertz, center point, not 0, center point 50. That's what. Okay. Now, I'm giving the proof also here. Suppose if XL is equal to XC, XL equal to XC, for example, what happened? Concentrate, guys, concentrate. First, which current is coming? I. So I'm taking I as the reference. I. Sir, based on this current, it will be magnetized. It has its own flux. So flux and current will be in phase with each other. It's a knowledge I have taken in the energy meter elaboratedly. Okay. Sir, this flux is cutting the coil. This flux is cutting this coil. If this flux is cutting this coil, automatically EMF will be induced. That EMF will be lagging the voltage by 90. Already we have taken. Clear? Okay. If XL equal to XC in the moving coil, definitely current will be in phase with the supply voltage. So therefore, IM will be here. Are you clear? So therefore, what we can write now? Therefore, TD equal to, generally, how many coils are there? 2 coils are there. I1, I2, cos of same concept. So therefore, what is it? TD equal to I into IM into cos of angle between these two, or we can say TD proportional to. Mutual in within, I'm taking only this one. Sir, TD proportional to I equal to, no problem. You can write, no problem. What is that? I into Im into, what is the angle between I and Im under this condition? What is the angle between I and Im under this condition here? 90. So cos 90. What is the value? 0. Therefore, what is the logic here? In that way only the instrument is designed. Means if the frequency is 50, because I'm designing for 50, that is called as the pointer initially at 0. The pointer is initially at 0. So therefore, force should not be produced. Means I'm taking the initial explanation, because I need to take explanation. Means the pointer is at one place, I have to take, that is initial value at 50 I'm taking. If it is at 50, right, therefore which one? If you are giving 50, the force should not be produced, automatically will not be produced, mathematically approved. Therefore, pointer shows which value? Yes, 0 only. Sorry, 0 moment only means 50 hertz only. Are you clear? If this terminology is clear, other terminology will be into picture. Can you respond, guys? Right? Now, what happened is the actual matter. Now, what happened is the actual matter. What is that? Kindly concentrate. Sir, if, second case, if frequency is greater than 50, for example, sir, 50, why means I'm taking normal as the 50, normal frequency as the 50. So that's why I'm saying that, yes, this is 50. Okay, suppose if unknown frequency, we don't know, if unknown frequency is greater than 50, if unknown frequency is greater than 50, what will happen? Concentrate. If unknown frequency is greater than 50, for example, what happened here? XL is equal to 2 pi FL. Frequency is more, XL is more. So automatically in the moving coil, inductive reactance will be more. Why? Frequency is more than the normal frequency 50. XC is equal to 1 by 2 pi FC. As the F is more, XC is less. So what is happening here? Therefore, what is it? XL greater than XC. But one small logic, people are writing like XC less than XL. Among these two, which is correct? Everyone, those on the line, kindly respond. Among these two, which is correct? First is correct or second is correct? Very nice. Yes, everyone has given that first is correct. Very good. Very nice. Yes, very good. C is fixed. C you are not changing. Why? C already fixed. With the current flow, magnetization will be there. Flux will be changing, means XL will be. That is the reason why you should say XL greater than XC. Of course, it implies XC less only. But if you write XC less than XL, it implies XC is getting reduced. No, XL is more. XL is more. That's why you have to write like this. Okay. Frequency more than the 50 minutes, automatically XL greater than XC. The coil is more inductive. The coil is more inductive. Under this condition, let me draw the phasor diagram. This is I. This is flux. This is induced EMF E as usual. Sir, XL greater than XC means in this more inductive is there. So IM lags the E by some angle. We don't know. So therefore, this will be IM. How much angle? Some alpha, something you take it. That depends on the corresponding frequency, how much you are given. So therefore, what is the TD? TD is equal to I into